All right, so um, our current model of the atom is not Bohr's model, but like I said, we'll continue to use that because it's a nice visual for what's going on with electrons. As you see, as we go through the quantum mechanical model, it would be a little messy to draw the atom the way that it would be with the orbitals that we're going to see. And so our quantum mechanical model um, does not restrict electrons to be in a certain spot. And so one problem with the quantum mechanical model is, or not the quantum mechanical model, the Bohr model is that it says electrons have to be on this exact path. We can't find it anywhere but this path. And scientists are like, whoa, the electron is moving way too fast. We cannot say that it's in one particular place at a particular time. We can't restrict it to that. And so a nice way to think about that would be this fan that I have in my room. And I know some of you have asked, Ms. Rawl, why do you have that fan painted those colors? And so as you can see, looking at my fan, I have a blue blade, a yellow blade, and a red blade. If I turn it on and those blades speed up, suddenly I do not see those individual colors at all. Instead, my colors blend together and merge. And so if I were to say, where is my blue blade right now? You could not tell me with any certainty. You wouldn't be 100% positive where it is, but you could have a really good guess. It's somewhere in this region, right? And so I know where it's probably at, although I do not know where it exactly is. And this is what the quantum mechanical model does. It tells you where your electrons probably are because there's no way of knowing exactly where it is. And so if I can get this switch back to my computer screen. We have a new model of the atom, which I know a lot of you have thought you've remembered, and that's our electron cloud model of the atom. And so the electron cloud model of the atom says that we are likely to find electrons in particular regions of our atom. And so looking at our atom, we have this cloud of probability where we're probably going to find an electron. And so like in this one over here, our electron could be found anywhere within this cloud. It's more likely to be found in this circle than outside this circle. And so we can see that by the color shown. Over here, we have a definite darker ring of dots around this ring, and that's where we're most likely to find the electron. In here, where it's a little lighter colored, we're less likely to find it. And so this is like a probability density picture. Our electron cloud tells us where we are probably going to find the electron, and the darker regions show you where you are more likely to find the electron. But again, this is the electron cloud, where you're most likely to find the electron. Now, one scientist pushes this a little bit further for us, which is Schrodinger. So Schrodinger comes up with this equation, and his equation gives us energies and energy levels in which electrons can have. In fact, his equation will also let you find the shapes of our orbitals. And so an atomic orbital is really just a region of space where, again, there's high probability of finding an electron. And so that's where we see our little clouds. We can have different energy levels. So much like Bohr said, that hasn't changed. And just like Bohr's atom, these should get closer together as you move further apart. Just usually not, we don't draw it that way, even though we know that's how it is. And so your energy level closest to the nucleus is energy level 1, then 2, then 3, then 4, then 5, then 6, then 7. And that could continue on. But those are the orbitals, the atomic orbitals. These are the places where we really have a high probability of finding an electron. Now, as Schrodinger studied, he actually found that within each energy level, we found energy sublevels. And so within each energy level, electrons could take part in a separate sublevel orbital. And so these energy sublevels have their own special shape. And again, Schrodinger's equation is what allowed us to find those shapes. I will post an extra video if you want to watch it. By no means is it required to watch, or do I expect you to understand how he knows these shapes. But knowing these sublevels exist is a big step forward in getting closer to seeing why we form charges that we do. And so these energy sublevels include our s orbital, which is spherical shaped. And so within each energy level, you can have one s sublevel. And so this would be our s sublevel. It has a spherical shape. Within each energy level, you can have 3 p orbitals. And they are kind of a dumbbell shape. So it kind of looks like if you held 2 balloons end to end, it has that dumbbell-like shape. A d orbital, there's 5 of those per energy level. And they're kind of like a clover shape with the exception of this middle one. And so kind of like a 4-leaf clover. And then your f orbital, there's no real good shape to explain it. It's pretty complex, but there's 7 possible for each energy level. Now, each of these orbitals can hold 2 electrons. So this s sublevel could have 2 electrons in it. This p1 could have 2. This p could have 2. This one, 2. This d could have 2. So each one of these holds a maximum of 2 electrons. Now, each energy level does not have all of these sublevels. And so it actually depends which energy level you're in, which sublevels you have. And so looking at energy level 1, you can only have one sublevel, and that is the s sublevel. And so if you can only have 2 electrons in that one sublevel, energy level 1 gets full with 2 electrons. If you're in energy level 2, you can have an s orbital and p orbitals. And since there's only one possible s orbital and there's 3 possible p orbitals, well, I know this one could hold 2 electrons, and each one of these could hold 2 electrons, so that holds 6. So energy level 2 fills with 8 electrons. Energy level 3, you can have all the SP and D orbitals, and so it can hold a maximum of 18. Energy level 4 and 5, they can have SPD and F energy levels, and so they can fill with 32. And so this is a good representation of what our probability looks like of finding these electrons in these areas. And so this center region would be like your first energy level, and that's the s orbital. This next red region is the second energy level and the s sublevel. And then these little purple balloons sticking off the end, those are the p orbitals, and that would be in the second energy level as well. And so this is an atom with electrons in energy levels 1 and energy levels 2, filling the s, and p sublevels. Again, I don't expect you to understand why all this works. That's for later college chemistry classes to understand that when you're a little more advanced. But again, this is going to help us see why we form those different charges, how electrons fill these orbitals. And so that's what's coming up next is electron configuration. What order do these fill, and how does that help us predict the outermost electrons, which is going to lead to our charges. So anyways, have a great day, and we'll talk about electron configuration next. Okay, bye.